All right, here's one that's kind of nicely set up for you. They kind of cut to the chase a little bit. So they give us a function, f of x equals x cubed minus 3 halves x squared minus 18x. Kind of looks familiar. And then they tell us the points that where we have where the derivative is equal to 0. So it says use the second derivative test to determine whether f has local maximum or local minimum at those points, right? So we actually did this one before with the first derivative test. So now I'd like you to try the second derivative test just to try it out. And so, but yeah, most of the time you'll have the choice, or a lot of the time you'll have the choice. There might maybe a few on the assignment where I ask you to do one or the other, and then, but for the most part, yeah, I want you to kind of pick which one you prefer. All right, so first of all, if we're going to use the second derivative test, we have to find the second derivative, right? And along the way, we'd have to find the first derivative. So go ahead and find the first and second derivatives here. All right, so I guess this one is a little different. I think it's the signs are different than the one we had before, but yeah, very similar. Anyway, so if you got those, great job. And so now what we want to do is, now that we have these zeros, right? And let me real quick show you how those zeros come about, just to kind of solidify that. All right, so once again, we could use a factoring or the quadratic formula. Since there's a GCF here and it came out to a simple quadratic, factoring is my preference, but that's another choice. You know, quadratic formula works great too. All right, so now that we have these values, now we want to use our second derivative to see if they're maximum or minimum points, right? And so, so what you're going to do is just plug these values in and see if the derivative comes out, if the second derivative comes out positive, that means it's concave up and you have a minimum. If the second derivative comes out negative, that means it's concave down and you have a maximum. Okay, so try that out. All right, so if you plugged in positive 3 and you got into the second derivative and you got a positive, you realize it was concave up, and realize it was a minimum, great job. And if you plugged in negative 2 into the second derivative and got negative 15 and realized it was concave down, then you got a maximum, great job. All right, and remember that we could find the actual values at those points. Like we could plug these into the original function and we can actually find what the maximum and minimum are at those points. But for right now, we're just finding where those happen, okay, and if they're maxes or mins. All right, so great work. Hopefully you have some good notes to take with you, and you know, bring questions as well to class or email me. And looking forward to working with you in class to practice this and master it.